Fresnel's BIPRISM. Before going for Fresnel's BIPRISm, once let us define what is interference. So interference means the modification or change in a resultant displacement. If two waves travel in same direction, then according to superposition principle we write it as y1 plus y2, with y1 as the displacement of first wave, y2 the displacement of second wave. If two waves travel in opposite direction, we write it as y1 minus y2. Okay. Now this resultant displacement will be different from this individual displacements. Okay. So this change or modification in resultant displacement or amplitude or intensity in superposition region, we call it as interference, right? The modification in distribution of intensity in region of superposition. Now next let us see what is coherence. Coherence means if any two sources maintain zero or any constant phase relationship between themselves, we call them as coherent sources. Now in order to get the sustained interference pattern, we require coherent sources. Then how to produce these coherent sources? So how to produce means by Fresnel's BIPRISm, Lloyd's mirror experiments, we produce coherent sources. Now interference, it is divided into two classes. One we call it as division by wavefront. Other we call it as division by amplitude. Now division by wavefront means the incident wavefront, it divides into two parts, and these two parts travel some unequal distances, and then after some time they reunite with each other and produce interference pattern. And the examples for this are Fresnel's BIPRISm and Lloyd's mirror. Similarly, division by amplitude means incident amplitude, it divides into two parts. They travel some unequal distances, again reunite with each other and produce an interference pattern. And the examples for these are Newton's rings, Michelson interferometer. Right? Now here we are discussing about Fresnel's BIPRISm, that is interference produced by division of wavefront. Interference produced by division of wavefront. Then what is the action of Fresnel's BIPRISm? Either Fresnel's BIPRISm or Lloyd's mirror, these produces coherent sources, because already I said that for having a sustained interference pattern we require coherent sources. That particular sources which maintain zero or constant phase relation between themselves. Now the condition for these are they maintain zero and constant phase relationship between themselves. Their amplitudes will be the interference conditions. One is we require coherent sources. Okay, the main condition. The second one is amplitude of two waves must be nearly equal to each other. They must travel in same direction, etc. These are the some of the conditions to produce sustained interference pattern. In that main condition is we require coherent sources. For that we are using FRESNEL'S BIPRISM. So FRESNEL''s BIPRISM means nothing but two acute angled prisms. We take two acute angled prisms placed base to base so that we get biprism. We take two acute angled prism placed base to base to get this biprism. Alright. Now, first let us see the action of this biprism. Okay. Now, first we are taking a biprism in such a way. This is nothing but the two acute angled prisms placed base to base give rise to biprism. Now this is the screen. Okay, in such a way. See the diagram here. Okay, the same diagram I am explaining. This is the screen GH. Now this is the eyepiece through which we see the interference pattern. This is the biprism and this is the monochromatic source. Here we are using sodium lamp. Okay, here we are using a sodium lamp. Now here what we said, when a wavefront is incident on this biprism, now this, let this be A, B, C you think. Now and this be some D. This sharp edge B will split the incident wavefront into two parts. This sharp edge B will split incident wavefront. Here is the required source. We are using sodium lamp. Monochromatic light means which has only single wavelength. That we call it as mono. Mono means single, chromatic means color. A single colored light or a single wavelength light, we call it as monochromatic light. So sodium lamp we are using. Now when the wavefront from this monochromatic light is incident on this sharp edge B, this B splits that wavefront into two parts. So one part we call it as upper half part, that is in ADB. So this one part goes in upward direction, other part in lower direction. Now this upper half part, it just bends and travel towards lower section. This upper half part of wavefront bends towards lower section or lower side and travels in such a way. Similarly, the other part is there, no? That is lower half part, that is DBC. Okay. Now this bends in upper section in such a way and travels in such a way. So upper half part bends towards the lower section. Lower half part bends towards the upper section. Now here our eyepiece is present, okay, through which we are observing what is happening. Now when we see through this eyepiece, we see that this particular ray is coming from source S1, and this particular ray which is traveling in upward direction is coming from source S2. When we see from the eyepiece, we see that this ray which is traveling in downward direction, the upper half part which bends and traveling in downward direction, appears to come from some certain source S1, from certain source S1, and this lower half part which bent in upper direction appears to come from certain source S2, okay. Now these S1 and S2, we call it as virtual sources. Actually these two parts came from S only, okay. From these S only we got these two parts. But when we see through this microscope, with this eyepiece, we see that one wave which is traveling in downward direction appears to come from this certain position, let us say as S1. The wave which is going in upper direction appears to come from this particular position, let us say as S2. And these S1, S2, we call it as virtual sources of this original source. Now here, condition for interference is satisfied. You see, what is the condition for interference? The incident wavefront must split into two parts. Here at B, the incident wavefront has split into two parts. They have to travel unequal distances. You see, one is traveling in some lower direction, other is traveling in upward direction. They are traveling in some different direction, some unequal distances in different direction. After that, these two waves again reunite with each other. So this is the condition for producing interference. So here the condition for interference is satisfied. So in this field of view, we find a sustained interference pattern, okay. And these two virtual sources, we call it as coherent sources. These two virtual sources of these S, we call it as coherent sources. In such a way, coherent sources are produced using Fresnel's BIPRISM. See here. Now the distance between virtual sources is 2D, and the distance between these virtual sources or coherent sources to the screen is capital D. And this is the field of view where we observe the interference pattern with the help of eyepiece. So in such a way, by using Fresnel's BIPRISM, we produce coherent sources.